everyone, welcome back to my placement journey. Today I am solving two very important coding questions that are frequently asked in TCS NQT and also asked in TCS. So if you understand these two, you will learn greedy approach, HashMap and the real TCS level thinking. So watch till the end because I'll also cover tricky test cases that most people get wrong. So let's start with the first question. We are given a number of months and we need to calculate the total SIM fee. So here are the plans like 1 month, 2, 3, 6, 9, 12. So the input which we given should be divisible by 3, 6, 9, 12. So now the tricky part is you cannot choose random months like 2, 5, etc. The input must be divisible by 3. If it is not divisible by 3, input should be error. Generally, to minimize cost, we use something called a greedy approach, right? This means always take the biggest plan. Like here, 12 months equals to 15,000. So take biggest plans. So let's take 12 months. 12 months is divisible by 3, right? Okay. Then we directly take 12-month plan, which is 15,000, and remain 12 months, again 15,000, total 15 plus 15, which is 30,000 we should pay. If we take 15, we should first take 9 months. 9 months means 12,000. Else 3 months will remain, no? So again 3 months means 5,000. So 12,000 plus 5,000, total 17,000 we should pay. Yes, 12,000 plus 5,000, total 17,000 we need to pay for the gym. Firstly, we need to check which it is divisible by 3 or not. Total cost or print error if invalid. If 25 is divisible by 3 or not? No, it is not divisible by 3. So, print error. Yes, print error. Use greedy approach. Always pick the largest possible plan first. As I said, this is the code. You can copy and analysis. First, if number is divisible by 3, okay. If not, then print error. Then while loop. Check for 12 months, 9 months, 6 months, 3 months. First initialized cost is 0. Then print cost. That's it. If you take 12 months as input, 30,000 will, as I said, 12 is divisible by 3. Yes. Sorry, 24 is divisible by 3. Yes, it will be 0. 12 plus 12. Cost is 15k plus 15k, 30k. 24 minus 12. 12 months remain. And again 15k. 15, 30k. The second problem is we are given n transactions. Each transaction has sender, receiver, and the amount and the timestamp. A fraud condition means a transaction is fraud if sender same, receiver same, and the amount is same, and the time difference is less than or equals to 60 seconds. Here we use a logic called HashMap. HashMap means key equals to sender plus a receiver plus amount equals to timestamp. Sender, receiver, amount and timestamp. That is input format. The logic is yes, HashMap. Use HashMap to store previous transaction and compare timestamps. Key equals to sender, receiver plus amount plus transaction T. Yes. Let's take input A, B, 1000 and 10. A is a sender, B is a receiver, 1000 is amount and 10 is a timestamp. And again A, B, 1000, 50. They compare the timestamp. 50 minus 10, which is 40. Is 40 is less than or 60? Yes. So fraud is detected. Okay, let's take another example. If it is 80 instead of 50, then the difference of the timestamp is 80 minus 10, 70, which is greater than 60, right? Greater than 60. So fraud is not detected. We only detect the fraud if the time difference is less than or equals to 60 seconds. But there 70, so no fraud detected. We always compare with the last transaction only, first and last. That's it. This is the code. You can check the code. We create a hash map for each transaction, create a key, check if it is exists, compare timestamps, and if it is less than or equals to 60, print fraud. Then update the map. It is the example as we shown before. So don't do common mistakes like comparing with all previous transaction. Only compare with last two only. Compare with the last transaction only. Don't compare all previous transaction. And not updating timestamp is a mistake.